Okay, so today we are going to start a new module or chapter. This is the last one, also known as the geostatistical analysis techniques. So, in order to know or in order to go into this particular chapter, I would like to remind you that we will be dealing or we will mostly be talking about some sort of mathematics and then statistics at the same time before we move on to the application of statistics in especially for GIS applications. Okay, so just I'd like to know, have you actually been taught about statistics in this course during some point of time during your mathematics class? Do you? Hello? Oh, can you hear me? Hello?
Yes, sir.
Oh, so what I ask you is, have you been ever taught about statistics in your mathematics class? Because you were almost towards the completion of your degrees. Have you been taught about statistics?
Yes, sir.
Okay. So, which semester did you learn about statistics? Hmm? First? Not first? Maybe second or third? Do you have any idea? Where did you learn statistics? Or what actually is statistics? So, statistics or statistical analysis is actually the science of collecting, exploring, organizing, and exploring patterns and trends in data. So, I don't know if you remember for this class. So in GIS also, we mostly deal with data and then we refine data and then it becomes information. But ultimately, when you want to extract some sort of meaningful information out of the data in your hand, you have to do some kind of analysis of the data or on the information. So basically, these tools in hands are similar the tools of statistics. So statistics, what we do in statistics is that it's statistical analysis is the science of collecting, uh, exploring, organizing, and exploring patterns of trends in data. So we are talking about data uh, from a population. So imagine if you have a population of 1,000 people in a village, and sometimes it is not possible to go and interview all the 1,000 people. Then you have to decide how much of a sample that you are going to take out of the population. So in order to do that, we have to apply some techniques which belong to the domain of statistics. So it starts from even collecting the samples. So statistical analysis is collecting, analyzing, exploring some of the trends in the data. So that data means your sample. And then from that analysis, we draw some inference about the total population of our importance or whatever you want to know about. Okay. So some of the common statistics that we normally deal with, or common tools that we deal with, we will be talking here in this particular chapter. That involves our mean. I must say that probably you have already studied about mean because these are some of the high school tools, mean, median, and mode. But even then, we are going to talk about these tools here in depth. Then one of the much talked about tool is known as the standard deviation. Then we will see what is the distribution of data. So what do you understand by the distribution? Then further on, we'll go for looking into regression analysis, and then how you determine the sample out of the population, and then how you do some sort of hypothesis testing. So if you imagine that you are going to test your hypothesis, there are standard tools. Okay. So first, let us start with a very basic thing, that is our mean. What is a mean? We all know, as you see here on the screen. Suppose you have 3 samples, okay, out of a population. Then those samples, they are having the values of 2, 3, and 4. So you want to know what is a mean. So mean is actually calculated when you add all these values together and divided it by the total number. Okay. So in this case, we have 3 values, and then when we add the values, it becomes 2 plus 3 plus 4 is equal to 9. And then when we talk about the mean, we divide 9 divided by 1, 2, 3. Since we have 3 samples, so 3 values here, then we have a value of 3. So mean is an important parameter which describes your sample. Okay. And later on you will know that together with mean we have 2 other important parameters, which is as shown here. The next one is known as the median. So what is the median? Median is the mid value or the middle value of a distribution. So in this case, our sample has 1, 2, 3, 4, 5 data, and then you arrange the data in an increasing order. Okay, so you have value 3, value 9, value 15, 17, and 44. So you have to first arrange it in an increasing order, because 44 is bigger than 17, 17 is bigger than 15. So you see, this is an increasing order. So unless you arrange your data in an increasing order, it is difficult to find the middle value or the median. So if your total sample size or total number of values is 1, 2, 3, 4, 5, it is an odd value, then it is easy to find the median. In this case, 15 is the median, okay, in the first case. Similarly, we have another sample where we have an even number of sample sizes or values, 1, 2, 3, 4, 5, 6 in this case. So this is our these are our samples, and then in order to find out the median, you arrange the samples in an increasing order, and in order once you do it, a median is found dividing these 2 middle values. Okay, that means 8 plus 12 divided by 2. In this case, it is 10. So if it is odd, this is a straightforward 15. If it is even, you get it by taking the half of these 2 median values. Okay, so median also, it is an important parameter of the sample size. You will later know. It relates or constitutes the middle value of a distribution. Okay. Then another important basic statistics is known as the mode. Mode is, what is the mode? It is the most frequent occurrence of a variable in the set or sampling of variables. So here, as you see, you have some repeating numbers here: 1, 3, 6, 6, 6, 6, then 7, 7, 12, 12, and 17. In this case, our mode is 6. Okay. Sometimes you have unimodal distribution. In this case, this is unimode. Sometimes you may have more than one modes. Okay. So then next is our standard deviation, which is much talked about. So what do you understand by the standard deviation? Standard deviation is the measurement of the spread of the values in a given data set. So that means if you arrange these values and then you want to plot the histogram, and then you will see that this histogram is how much deviating from the mean value. So once you calculate the standard deviation, it is a measurement that will exactly or precisely tell about the spread of the values in a given dataset. So if your higher is the standard deviation, that means the less numbers in the set and it tends to cluster near the mean. Okay, so sometimes if you fit a curve into the distribution, you will see that it becomes a bell-shaped curve, and depending on the value of your standard deviation, that spread of the curve may either be tightly packed or sometimes it may be sparsely packed. So anyway, how the standard deviation is calculated. Here you have an example here. So our data set have values of 12, 55, 74, 79, and 90. In order to find the standard deviation, first of all, you have to find out the mean of this data set. So how you calculate the mean? You calculate this mean by simply adding all the values and dividing it by the total number. Okay, how many counts? 1, 2, 3, 4, 5. So in this case, 12 plus 55 plus 74 plus 79 plus 90 divided by 1, 2, 3, 4, 5. So in this case, you get a mean of 62. And then in order to find the standard deviation, you have to find the difference of the mean from each number, and then you square these values and then add it up. And then again, you divide that summation by the total number of values. In this case, it is 5. And then you arrive at the standard deviation, which is 27.4 here in this case. Okay, so these are some of the very few basic parameters that describes the data set in a nutshell. Okay, then then we talk about, or the next is the distribution of the data. So when we talk about distribution particularly, it is actually, from a practical perspective, we can think of a distribution as a function, okay, that is capable of describing the relationship between observations in a sample data set. So depending on the data type, we have different distributions in this case. Some of the distributions you'll see later that it is either normally distributed, or you have a binomial distribution, or you have uniform distribution, or you can have an exponential distribution, different kinds of distribution. So in another way, you can tell the distribution as it is a function that shows the possible values of a variable and how often they occur. Okay, so distribution is also somehow related to the probability of occurrence of a value in a data set. So for example, the simplest form, we can talk about the distribution when you roll a dice. Okay, it should have been a dice, D-I-C-E. When you roll a dice, and then we can talk about the distribution here in this case. For example, you have a dice, as you can see it on the screen. So you have different values on the dice. You have 6 faces of the dice, starting from 1, 2, 3, 4, 5, and 6. Okay. So in this case, you roll the dice. You throw the dice, and then you expect some value to occur. Okay, and then every time you throw the dice, you have a probability of occurrence of a particular value. So in this case, the dice, when you throw, or someone throws the dice, it can either be 1, it can either be 2, it can be 3, it can be 4, it can be 5, it can be 6. Suppose you were throwing it 6 times. So all these values, they have certain probability of occurrence. So if you have 6 values, each time, because they are not related to each other, it has an independent probability of 1 divided by 6. Okay, so that means if you throw a dice, it may be 1, it may be 2, it may be 3, it may be 4, it may be 5, it may be 6. All these values, they have equal probability of occurrence. In this case, this is 1 by 6, which is almost 0.17. Okay, so but if you throw the dice infinite number of times, even if you throw the dice, you can only get these values. Okay, these values are, what are the values? These values start from 1 and then they go up to 6. Okay, there cannot be any more values except these values, these 6 values. So in this case, the number of expected values are actually discrete. That means these are already known. Okay, you cannot get either 0 or you cannot get the 7. So you see in the next diagram here, even if you throw the dice infinite number of times, you cannot get a 7 or you cannot get 0. That is quite impossible. So you rule out all other values except these 6 values. What are the values? 1, 2, 3, 4, 5, 6. And these values have equal chance or equal probability of occurrence every time you throw the dice. And that probability of occurrence is 1 divided by 6. And remember that 1 to 6, these are discrete numbers. Okay, in this case we call it discrete random variables. Why these are discrete? Because they are not, you cannot expect 1.25 or you cannot get 3.14, you cannot get 5.67. You have only these 6 numbers. Out of these 6 numbers, you will get whatever number of times you throw, the values will only repeat these. Okay, and these are random because suppose next time or this time you got 2, next time whatever value that you will get, it is not dependent, either you have got 2 or 1 this time. So these have equal chances of occurrence and then they are random. Okay, so in our statistical analysis also we make some assumptions. Okay, we make some assumptions. We make the assumptions in such a way that some all the sorry in most of the cases we assume that the events which occur in nature, they are of random nature. That means they are not influenced by a preceding event. Okay, later on you will come to understand that. Okay, so in this case, when we are talking about distribution, as I said, the distribution is actually a probability function. Okay, so occurrence of 1 is 1 by 6, which is almost not exactly equal to, but almost equal to 0.17. Occurrence of 2 is also same, 1 by 6. Occurrence of 3 is almost same. So all the 6 values, they have equal probability of occurrence. And when you add up all these probabilities, this will be a total of 1. So in that case, you can say you are sure that you have exhausted all possible values when the sum of possibilities is equal to 1. For all other values, the probability of occurrence is 0. Okay, so we have some discrete values, only 6 discrete values here, in case if you are rolling a die. So what I'm talking about a distribution, so if you plot these probabilities, okay, so if you plot these probabilities, you see here on the y-axis, you were plotting these probabilities, and then on this x-axis, if you were plotting the values, okay, this case, it will give you a distribution. So in this case, all the distributions, they have equal probability of occurrence. So for example, occurrence of 1 is 0.17. Occurrence of 2 is 17, 3 also is 0.17, 4 is also 0.17. So 5 and 6, they also do have the same probability of occurrence, which is 0.17. So in this case, it is a uniform probability distribution. So here you say we have equal probability of occurrence, and then this distribution is known as uniform probability distribution, or in short, we can say uniform distribution. But remember, it is a discrete random variable. Okay, discrete. That means 1, 2, 3, 4, 5, 6. These are only very separate and individual numbers. Only 6 numbers only. We cannot have more numbers in this kind of an analysis or event. So each probability distribution is associated with a graph. In this case, this is the graph which describes the likelihood of occurrence of that event. For example, the likelihood of occurrence of 4 is 0.17 here. So this is actually what is known as a probability distribution in statistics or simply distribution in statistics. So from here we go a little farther, then we take an example of throwing two dice, okay, or two dice at which earlier it was only one dice. So if you throw two dice, then you'll get a combination of two numbers, okay, or two values. So these combinations are here, as you see it in the screen. It can be 1 1 or it can be 2 1. 1 means for the first dice you get a value of 1, for the second dice you get a value of 1. Again, if you throw, suppose you get a value of 2 in the first dice and then 1 in the second. So in total you get a value, you get a combination which is 36 number of different combinations which are possible. Okay. So see, only two dice, the picture changes quite significantly. So if you roll two dice, or you have two dice that you are throwing, then you get a combination of 36 total number of different combinations, as you can see it on the screen. So if you go further to find out the probability of occurrence of either 1 1 or 2 1 or 3 1 or 4 1 or 5 1, so here on the screen, as you see, if you add these values, 1 and 1 is 2, ultimately 2 and 1 is 3, 3 and 1 is 4. So from 2 to 12 only you have the total number of values as an outcome. So each values are associated again with a probability. So if you see the total the proper probability of occurrence of a total value of 2 is always 0.03. Then again 3 will be a little bit more than that, 0.06. A total number of 4, if you throw two dice, it will be 0.08, 5 is 0.11, 6 is 0.14, 7 is 0.17. And then again, if the total number goes on increasing, this probability starts decrease. Okay. So as I said, what would be the distribution in this event? So the distribution is when you plot the probability of occurrence on the y-axis and on the x-axis, it is the total number which actually is given by the two dices. In this case, it is two dices. So you see the probability of occurrence is 2. 2 is 0.03, 3 is a little bit more than that. And then when you come to 7, it has the maximum or the highest probability of occurrence. In this case, this is 0.17. So in this case, we do not see a uniform value associated with all these total numbers. Okay, so you cannot say this is a uniform distribution, but at the same time these are all discrete numbers. You see, our numbers can only vary from 2 to 12. This is an example when you throw the dice. But sometimes in nature there are things which are not discrete. Okay, in that case we term them as continuous or continuous random variables. A very good example of a continuous random variable is the heights. Okay, sometimes suppose I am totally I don't know about the heights of everyone in the class, and then I went to the class and then I started measuring the heights in the class. So whatever values that I can get 150, I can get 150.1, I can get 150.2, I can get 150.3, I can get all the possible values from 150 to 160, and not only to 160, I can get all the possible values from 150 to 170 or 150 to 200. This is just an example. So someone may have a height of 160.5, someone may have a height of 163.7. So in that case, we have these variables which are not discrete. Okay, we cannot say that only we will get 150 or we can get only 60, 170. No, we will get a value that lies in the interval of 150 to 200. So any possible values may occur. So even then, if you plot the probability of occurrence of these sort of intervals, then you will get this probability of occurrence on the x-axis, and then this will be taking a shape as you see it on the screen, which is uh, actually inverted, or I think it is a bell-shaped curve. Okay, so in this case also we have our mean, we have our median, and we can find our mode. Okay, so in case of continuous random variable, so what is a continuous random variable? A continuous random variable can take on an infinite number of possible values. So for example, it can take any value between 3 and 4. Not in this case, but for example, it can take any values between 3 and 4. It can take any values, or you can say between, which is more than 0. So all things are possible here. So in order to model the data set, okay, so we cannot model a continuous random variable with the same methods that we model a discrete random variable. So the tools in our hand will be different. So in that case, if you go to the field and then you ask, you want to measure the income, or you want to measure the heights, okay, or you want to measure the total number of population in a household, this will fall into different categories of variables. For example, the number of people which will be in a particular household, it cannot be a continuous random variable, because people numbers are discrete. Okay, either there can be one people, or two persons, or three persons, or four persons. There cannot be 2.5 persons or 3.7 persons. But on the other hand, if you go and measuring the heights of these people, in that case it will be a continuous random variable. Okay, so same whatever your same questionnaire, whenever you will be taking to the field, or whenever you are taking up a research, it may generate some discrete variables, and at the same time it may generate some continuous variables, assuming all are random. And then from the same questionnaire, you will have different tools available for analysis of these different sorts of data or variable. Okay, we model a continuous random variable with a curve. Okay, so if I want to give a mathematical expression to this curve, which can be a function or fx, and then it will be called a probability density function, or PDF, in case of a continuous random variable, as you see it on the screen here. Okay, so in case of a probability distribution function, here this one will be knowing as PDF, which is actually a function, y is equal to fx. So we have some sort of a function here. Okay. 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 So here on the screen, we have some talking again into some in depth of the continuous random variable. This is very interesting. The continuous random variables, when you have a function, then the probability for individual values are actually 0. If you take this function of this bell-shaped curve, as you see here, and if you ask me what is the probability of finding a is equal to 3 point or x is equal to 3.12345, okay, exact value, that is actually equal to 0. So when we talk about a continuous random variable, we talk the probability in terms of intervals. So we talk about an interval between A and B, and then this probability is given by the area that has been confined within these two limits or variables between A and B. So in this case, the probability is between A and B is the shaded area in the curve. As you see, probability of A less than X, which is less than B, can be found. Okay. For continuous random variables, probabilities are actually areas under the curve. So the area under the entire curve in that case will become or will be equal to 1. Okay. So probability that a random variable is equal to a particular value is always 0. We cannot find a particular probability of a particular value, but we can talk about probability of an interval, okay, which is given by the area that will fall under that interval. In this case, the interval is from A to B, and then the probability of that, those two values, whatever A and B may be, will be the shaded area in that particular curve. From a practical point of view, it makes sense to talk about a random variable x falling in an interval of values. Okay, so here the interval is between A and B. Okay, so which earlier was, if you look at discrete values, it was somehow different. Okay, in C, so discrete values for a probability of 4, you had for a value of 4, you had a probability of somewhere 0.08. For a value of 5, you had a probability of 0.11, which is not so in the case of continuous variable here. So we cannot talk about a particular probability of finding a particular value in case of a continuous variable. Rather, we talk about an interval. Okay, that is why. Okay, so depending on the shape of these probability distribution functions, there are different distributions which are named. In this case, if the shape is like this, this is a normal distribution, and in case of a normal distribution, we have a particular distribution function mathematically, which I will show you later. In this case, our mean, whatever will be the mean, will be equal to the median, and then it will be equal to the mode, in a perfect normal distribution like this one. Okay, normally our mean is equal to median, and then it is equal to mode. It is a perfect bell-shaped curve like this, and you can actually fold these into two halves, and then you can fold it along the mean or the median or the mode. Okay, so in our y-axis, this is our function y or fx, and this is our x. Again, for another continuous random variable, if it is shape is like this is also known as uniform distribution. Or sometimes the data in nature may have a distribution like this one, which we can say it is showing a distribution that is somehow exponential. So what are some of the examples of exponential distribution? Like the exponential decay of radioactive materials, okay, in the environment. Along, if you plot it somehow x time in the x-axis, and then the decay, it may follow a curve like this, and then it will be somehow falling into category of exponential distribution. So there are various different kinds of distribution, and you need to know what your data set actually falls into, what kind of a distribution, before you really go for analyzing those data set. Okay, so far we have known that the equation used to describe a continuous probability distribution is called the probability density function, or PDF, All probability density functions satisfy the following conditions. What are the conditions? Number one, the random variable, or y in this case, is a function of x, that is y is equal to fx, as you see here. Okay, y is fx. The value of y is greater than or equal to 0 for all the values of x. So as I said, in this case, so your value of particular value of probability of a is cannot be 0. It is always more than 0. Okay. The total area under the curve of a function is equal to 1. And then your probability of finding particular uh, uh, probability of under the shaded area for the whole curve actually is 1. So again, the random variable, when we're talking about a normal distribution, as I said, there is a standard equation that has to be satisfied in the data set to be normally distributed. Or if you have these parameters, you fit into these equations, whatever data will be generated will be will be normally distributed. In this case, what is the distribution function here? It is known as a normal equation. Y is 1 upon sigma multiplied by square root of 2 pi, and then which has a bracket closing, and then this e to the power minus x minus mu square divided by 2 sigma square. So in this case, we have this sigma, which is the standard deviation, and e is epsilon, which is approximately equal to 2.71828, and our pi has a value of 3.14. Okay, and then this, if the data you are generating out of these parameters, if you're feeding the standard deviation into the equation, if you know your mean, which is the mu in this case, you will get a function of y. Your data set may be taking a shape like this, which is tightly packed, or your data set may have a spread like this, which is having a larger spread. So in either cases, both are normally distributed, but in this case, it has a smaller standard deviation, and in this case, it clearly shows a larger standard deviation. So this is actually somehow some of the basic things which you should a little bit brush up before we go for the application areas of these statistical parameters into GIS. So later on, maybe in the class tomorrow, if I may, then we will talk about regression models, and then what is a Thyssen polygon, and then we will go to describe the IDW techniques, or inverse weighted distance, and a few others, okay, which is actually relevant in the case of GIS or in the natural world. Okay, so do you have any question? Why everyone is so silent? No question? Everything is clear? Oh, sir, I cannot hear your voice. Are you hearing me? Hello?
Yes, sir.
So someone says I cannot be heard. But anyway, okay. So if you have no question, then I'll stop here for the time being, and probably I will take another class, not tomorrow maybe, but on Thursday. Tomorrow is Wednesday, right? Tomorrow is Wednesday, so probably on Thursday I'll take a regular class of 2 hours, and then we will start from here. Okay? Okay then. See you again.